Hello everybody, this is the video tutorial for the 7323 CAM Rev 0. And you should be able to import this SOLIDWORKS file. This one imported with the front facing away, so what we're going to do is we're going to look at it at this orientation, and we're going to do something here. Set our current view as home, and we're going to fit to view. Okay, and then now if we hit home, it'll return to that view. Okay, and we've imported this from SOLIDWORKS, and the naming convention's a little bit different. So what we want to do is we want to go to our file, right click, rename. You're going to put rev underscore 0 underscore your first initial and last name, and hit enter. Okay, and that way we got it in the proper naming convention. Now we're going to go get your stock that you modeled for this and should have already programmed is the different part number. It's the 7333 Rev 0. And we're going to pull that into this model. Okay, we're going to expand that model and we're going to hide the V block and the vise. We don't need those items. And let's drag this over and let's take a look at it in orientation to our part. And it looks like, to me, the pin is in the right place the way I modeled it. If it isn't for you, you'll need to rotate this so it does line up. We're going to hit OK. And I'm actually going to go to bodies and I'm going to hide what was the stock for the 7033. And this is actually what we're dealing with. The 7033 is now the stock for 7323. And what was labeled stock here was within that part. Okay, so now what we're going to do is we're going to go to assemble and we're going to do a joint, and we're going to pick similar surfaces. Okay, so whether they're edges or a surface, you need to pick with the same origin place. And again, if this pin doesn't line up, this is the point where you need to do a rotation to get that pin to match. Okay, we're going to hit OK. And I'm going to go back to my home position. And we should see a witness line of the finished part here, and this is actually a finished surface on the part as well. Okay, now what we need to do is we need to bring in our rotary axis. So we're going to go in and we're going to take our Sierra College HRT 160, bring that into the model as well. Mine happens to be orientated correctly with the pin in the up position. Doesn't necessarily mean yours is going to be. If you need to reorientate it, do it at this point. We're going to hit OK. Okay, so we're going to assemble these. We're going to go to Assemble, Joint, and on our fixture, we're going to pick the face where it's going to register. And we want it to snap point to the center of that diameter. Okay, and then on our part, it's not this boss. This boss goes down inside the fixture. We want this face to be the alignment because there's a 100 thousandths clearance designed in the fixture so that that boss doesn't bottom out. So we're going to pick the outside, or the chamfer that's at the top of the feature, and it should align like this. Okay, if you've done it right, you should be able to zoom in and see the chamfer still visible. If you didn't, you selected the wrong side of one of the chamfers on one of the two parts. Okay, next, go back to home. Next, we need to adjust the length of the shaft stick out, and so there's a dimension in the TRT and the HRT model that can be changed for that. So temporarily, we're going to hide both the model of the stock and the model of the part itself. And if you zoom out, you should see some numbers appear. It's unfortunate Fusion does it this way, but we double click on it, and we need to make this number 2.51. And that should put this at the distance of the face of this nut right at the end of our part. So let's make that visible, the part visible again, and see if it is. And it should be. Okay. Okay, now we're going to go ahead and turn our 7333 back on. This is what it should look like. Make sure you've saved. Okay, so we're going to go from design to manufacture. And it's going to pop up with this window, insert manufacturing data. That's from your 7333 part. We don't want that, so we're going to hit cancel. Now we're going to create our setup. So we're going to go new setup. And it's initially going to try to make the stock the entire assembly. That's not what we want. We're going to go to expand our models. Expand the 7333 as well so we can see both the bodies. And our model is going to be the 7323 model. And then we're going to go to the stock tab and we're going to change this from relative size box to solid. And we're going to select the 7333 model. It should say 3 inches in all of these boxes. Then we can go back to our previous tab and we're going to change the orientation to Z-axis plane and X-axis. Select the top of the rotary. Select a line that's in the X-axis for the rotary. And our origin is going to be model box point. And we're going to select the one that's at the center front of our workpiece. We're going to go to the post-processing tab and we're going to number this 7323 first operation, op 1, work coordinate system 2. Make sure you're using work coordinate system 2, that's G55. We're going to select OK. Now we're going to go to the setup and we're going to type op 1 and we're going to go ahead and put a note for axis so that when we're post-processing we know whether this is a 3-axis, 4-axis, or 5-axis routine. And we should be good to go. We no longer need the model visible for the 7333. The information is now embedded in the stock. And so we're going to collapse all this down. We shouldn't have to turn that back on. Now in this project we're going to cycle through what are the rotary commands. They're called multi-axis, but they're pretty much only used to spin apart in a rotary axis. So the function actually is 4 axis. The 5th axis capability of it is able to tilt that axis so that you could say do a cone. But in essence, this works the same in 4 and 5 axis. So it's truly more of a 4th axis type of command, but used often on a 5 axis. Okay, so we're going to go to rotary pocket. That's our first one. That is the closest thing we have to a true roughing cycle that can take off different depths. There's rotary parallel, contour. There are 3 rotary commands. We are going to do 4 routines to make this part. Our rotary pocket, and we're going to select an end mill for that one. So we're going to go to our library and we're going to go to our 1/4 inch flat end mill. And we're going to select that tool. Keep the default feeds and speeds. On multi-axis, this is important. We're going to use, you have different options. You have model orientation. You're in line with one of your axes, rotary axis, and coordinate system. We're going to use setup x-axis, and the reason is your x-axis is not necessarily on the spin center. So you want to make sure that if you're doing 5-axis, you may have a different location for it. It should pop to the center of the part because that's how we set it up and because of our stock settings. Now we're going to go to Geometry tab, and this is where we tell it what's front and back of the part. You notice mine's flipped. It may have to do with how it was modeled originally. Okay, so it's flipped backwards. You can just flip it so that like this is front and you could select front of the model, which in this case would be probably fine. But I'm going to do selection. I want to make sure that I get the right location. And we definitely would not want to use that option on the back of the part, because we're actually not machining to the back of the model, it's embedded in our fixture. So the area we're going to machine is from this edge, because this diameter is already finished from the 33 stock. So we're going to go from selection, and we're going to pick, you can pick either the surface or the edge in front of that flange. And so we should be restricting our stock removal, or what it processes stock between those two planes. Okay, we're going to go on to radii. Okay, and this is setting our diameters for our stock, or processing of what to machine. So we're going to go with stock OD, but our stock ID is based off a 1/2 inch hole in the center, and that's not what we want. We want to change this to selection, and we're going to select the diameter of the neck. Okay, and that's the smallest diameter we want to machine, and we don't want it to go any farther than that. Okay, we're going to go to the next tab. Okay, we're going to go down the line. We're going to leave all these at default. Make sure your step over is an 1/8 inch, that's half the diameter of the cutter. And we're going to do order by depth on this one. So it's going to work from the outside in. And on our rotary passes, we want to switch this. So there's two modes this can work in. Its default is offset, so it's going to follow whatever the profiles are, and rotate the rotary. We want the second option, which is offset and spiral. So if it's truly a cylindrical area like the neck down area, it's going to just spin in a spiral fashion. So we're going to go offset and spiral, and we're going to set this tool offset. What the tool offset does is it offsets the diameter, the tool, so that the center point is not 90 degrees to the workpiece, and it allows it to cut a little more efficiently. Okay, so we're going to put 0.1 there. Yeah, we don't want to go half the diameter, but that's pretty close to it. Okay, and then we're going to do automatic step downs, and our maximum step down is going to be an 1/8 inch. We want to do a step down on floors. And our cutting approach, we do want it to approach from the front of the part, but we do not want it to approach from behind that limit that we selected. We don't want to ram into this fixture. And then on stock to leave, we're going to put in a little bit more. 1/4 inch end mill can flex a little bit, and that's going to be 40 thousandths. And for those of you who are metric, that's 1 millimeter. We're going to go to the next tab. And I believe we're going to leave most of this at default. And again, we want to go beyond the front limit with our lead ends, but we don't want to go beyond our back limit. So make sure that only the first box is selected there. We're going to hit OK. Okay, and it processes around, and it's doing pockets, zigzags, and some rotary moves to clear out the majority of the material, working from the outside in. Okay. Alright, I'll let you simulate it. There's no point in you watching me simulate it in my video. Okay, next, the next feature we want to cut is the other rotary commands are not very good at doing vertical walls, like this wall and this wall. And so we left a millimeter or 40 thousandths on those faces, and we did not cut them right to their numbers. The rotary pocket does a pretty good job at that. So what we're going to do is we're going to right click on our rotary pocket, and we're going to duplicate that pocket, and we're going to change some parameters. Let's go to edit. We'll keep the default feeds and speeds. Okay, we're going to go to multi-axis, and we're going to keep it at setup x-axis, which was on the previous settings. Our geometry we do want to change. So we're going to clear out both these faces. So we want to reset those. We're going to select our front face as the leading edge of the slot. And then our back face is going to be the back edge of the slot. So you can select surfaces or edges, but those two star shapes. Now, we don't want our flat end mill. We want it to cut right to the finished numbers on these two faces, but we don't want it skimming across these surfaces and doing lead ends on them. So in order to contain that, we need to put in a 0.12 distance here and negative 0.12 distance in the other direction. This is not quite half the diameter of the cutter, but it'll keep it from trying to lead in off the workpiece. And even if you have the ideal conditions, when we come back with another cutter to skim this off, you'll see witness lines for that flat end mill if you don't do this. And we're going to select rust machining, so it's only going to machine material that isn't there. So it's not going to spend a bunch of time clearing out the center of the slot. Okay, we're going to move on to the next tab. And our radial cuts, we're going to go from selection, and we're going to select this outermost part of this part of the model. Okay, it's a little bit smaller in the diameter of the flange here. That's where we're going to start our cut. And then we're going to deselect the face we selected, and we don't want to go all the way down to that face for the same reasons. We don't want gouging here from this cutter with another cutter going over. So we're going to pick the top of the fillet, and then we're actually going to put in a little bit of a clearance. So we're going to put 0.005 and bump that out so it won't go quite to that, and we'll rely on the ball cutter to make that transition. We're going to go to Passes tab, and on the Passes tab, we want to deselect the order by depth, because in this case we want to go down each face consistently. And we're going to leave the rest of this the same, except we're going to deselect automatic step overs. We're just going to do 125 step overs, and we do want to finish on floors. And we do not want to go beyond the front limit, and we do not want to leave any stock. We're going right to the numbers on this one. So now we're going to go on to the linking tab. We're going to keep all this stuff at the top at default, except for we're going to deselect front limit. We don't want to go beyond front limit with our lead-ins. We want it contained within this slot. And then we'll hit OK. So we can see our moves, and everything should be contained within the slot. Okay, and we get finished faces. It is going to leave material where the previous cutter left in the corner, and we're going to clean that up with a ball cutter with the next routine. We're going to rough it closer, and then we'll do a final finishing. Okay, so you notice you have this stair stepping, and we put 40 thousandths clearance. Well, that 40 thousandths clearance is really the minimum amount of material between the model and this end mill cut. So in a lot of places, there's more than 40 thousandths of extra material. So that's why we're going to go in with the next tool. One is to learn the tool, and the other is to clean it up closer before we do a finish cut. So now we're going to do the rotary contour command, which is more effective for fins, things that aren't necessarily cylindrical, like helical faces, propeller fins, and that kind of thing. We need to select from our library the 1/4 inch ball end mill. And I want you to double check the length below holder. If this says 1 inch, you're going to need to edit this tool. So we're going to edit this tool, and we're going to go to cutter, and we're going to set this at 1.25 below holder and hit OK. If it already says 1.25, you're good. Select it. We're going to make sure the tools are out the correct length before you come into lab. Alright, so we're going to increase our speed on this, because we're going to cut faster than we would normally with this, because we've removed most of the material. And we shouldn't have even close to 20% of the diameter engaged. So we're going to go 7,000 RPM. And the way this cut works is sideways moves and plunges are really sideways moves. They're not like a pocket where it's plunging straight down. So we're going to go 40 inches a minute on all of this. I'm not certain the rotary can go that fast, but the linear moves at least will be faster. This part is going to be difficult to get done in one lab period. which is our multi-axis. Okay, and we're going to select our x-axis, and there's nothing else to do on that tab. We're going to go to the geometry tab, and we have to do the same routine here where the front of our stock, we're going to do selection, pick the front face, and then the back selection is going to be this face or this edge, either one. And that's where we're going to be machining in between. And we are going to pick the rest machining box that should only process material that was left by the previous operation. And again, you can do a fixed tilt cone. That would be for 5-axis. It's just going to tilt the rotary in one angle and then spin. Okay, we're going to the next tab, radii. Okay, we're going to stick with model OD on this. Okay, is our outside edge. And then our inner radius is not going to be this cylinder in the center. It's going to be selection. And we're going to select the next section there. Okay, and then we're going to go to the next tab, which is the passes tab. Okay, we're going to leave a lot of this at default. We are going to do a step down of 30 thousandths instead of 40. And we're going to do a step down on the floors. And our stock to leave is going to be 40 thousandths. And we're going to turn on the smoothing deviation this time. And we're going to leave that at 2 thousandths because this is still a roughing cut. We're going to go to the next tab, the linking tab. And we can leave everything at default. We want beyond front limit selected. We're going to hit OK. Okay, so we have it leading in here. We got kind of a spiral move, and it's going to go around and knock off the edges, but still leaving a minimum of 40 thousandths on every surface, except for these two that are already cleaned up. It's going to just skim right past those, and it'll take down the fillet a little bit for the next cutter. Okay, now we're set up for our last routine, and this is going to be a rotary parallel command. So we're going to go to rotary parallel. Okay, and as it's shown in the graphic, that's one axis you can go in, but we're going to actually do a spiral, more like cutting on a lathe. Select rotary parallel, it's great for finishing, and we're going to leave our default feeds and speeds high, like we have. We need to move quick because we're going to be doing small step overs. Okay, and then we're going to change our axis to x-axis. On the next tab, geometry, we need to do our similar setup here. So we're going to do the front is going to be selected at the front of the part. The back is going to be a selection point that's the front rim of the flange. And we're going to move on to the next tab, which is radii. We're going to go from model OD. What's disturbing to me is I wish we could set an inner diameter limit like on the other commands. Fortunately, it doesn't. So it's not how it works. But this blue should be a cylinder we can select. You can do avoidance in geometry selection if you need it. I don't believe we need to in this case. And we're going to go to the passes tab, and we're going to change our step over. We're going to go 0.01 or 10 thousandths. Now if I was cutting this and I wanted a nicer finish, I'd do 5 thou, but we don't have enough time to do that in lab. And then we're going to do spiral. Now you could do spiral, circular, or line. Line's going to go in the opposite direction, back and forth for this type of part. It's not too appropriate if you're doing like a gear or something. That might be a better way to do it. Or a spline. Spiral and circular are very similar. Circular is going to go in circles, and it's going to have a linear move at one point every single time in that circle, which leaves a witness line where that X move goes in. So I prefer spiral. It's just going to start and continuously cut from one end of the part. So we're going to use spiral, and we're going to leave the rest of these options alone. And then we're going to go to the linking tab, and we're going to leave all that at default and hit OK. Okay, so it should spiral from one end of the part, from the front to the back. It's rolling over the edge a little bit on the front, but not enough to be concerning. And we should get a pretty nice finish on our finished part. The only clearance issue we need to look at for is at this point, and if we have this running at 1.25 long, which should be fine. All right, please reference the documentation on how to post-process this. Should be good, and thanks a lot, and I'll catch you on the next one.